Okay. So we have discussed TCP with respect to TCP services we have done, futures we have completed, state transition diagram we have done. Then we also considered error control, flow control, congestion control of TCP. Okay. So in handling many things, we may be interested or we may be in need of TCP timers. That topic we will be discussing now. Okay. So if we consider TCP, we are going to have 4 different timers. One is retransmission timer, another one is persistence timer, keep alive timer, time wait timer. Okay, these are the 4 timers we have in TCP. Did we hear any timers previously?
Yes.
Anybody? Which timers we have seen previously?
Retransmission and persistence time.
Retransmission and persistent timer. Okay. So any idea when we talked about persistence timer?
Deadlock is
Exactly. Whenever we have deadlock, but because of what we are getting that deadlock situation?
Both server and client will be in waiting state.
Somebody is saying something, but I cannot hear. Can you repeat?
Both the client and server will be in waiting state, sir.
That is fine, but when these two will be in waiting stage?
Receiver windows will be 0, sir. At that time, the client will be keep on sending 1 byte, but it will not reach that receiver.
Okay, basically you have receiver has said receiver window size 0.
Mute, sir.
Audible now?
Yes,
yes, sir.
Okay. So in TCP, there can be only one RTT measurements running at any time. That means, for example, let us say I transmitted one segment I have transmitted. So I will start this round trip time measurement. Okay, how much time it is taking for me to go to the other side and get an acknowledgement. I will also, let us say, sending second segment, but I am not going to measure round trip time here. Okay, if you remember, with respect to data link layer, we have seen we are going to start timer for each and every segment, but in the case of TCP, we are not going to do like that. Okay, that is what we are saying here. There can be only one RTT measurements in progress at any time. Okay, and how we consider the amount of time second segment is taking or third segment is taking is we are going to consider what is the offset value we have. This is the starting point, right? So what is the offset after which second one is set? What is the offset after which third one is set? Like that we will be having measurements. Okay. So with respect to retransmission timer, previously also we have seen, we'll try to discuss again. Whenever TCP sends a last segment, it creates retransmission timer, okay, for particular segment. Here we can have 2 situations when we actually do this one. For example, if an acknowledgement is received for this particular segment, before timer goes off, we will be destroying the timer. Okay, let us say I send a segment, okay, and here I am starting RTO, retransmission timer. Let us say at this particular point, okay, the retransmission timeout happens. I'm just considering timelines. At this point, I am considering retransmission timeout happens. Okay, within that, I am going to get acknowledgement, let us say. In that case, timer will be destroyed because there is no point in keeping the timer still, right? Because we already received acknowledgement. Okay. If the timer goes off before the acknowledgement received, then the acknowledgement is retransmitted and timer is reset. Okay. So let us say we are not getting that acknowledgement before this timeout happens. In that case, we will be retransmitting that particular segment. Okay. So that is what we are considering the role of retransmission time. And this round trip time, it is measured based on measured RTT, smooth RTT, deviation RTT. Okay, we have three different round trip time measurements. Okay, measured RTT, smooth RTT, and deviation RTT. Using all these things, round trip time is measured, but we are not looking into all those calculations. We are just looking with respect to what is the concept of retransmission timer, when it will be used. Okay. Next we have, okay, TCP does not consider RTT of a retransmitted segment in its calculation of new RTU. Okay. Basically, we said we are calculating RTT, right? Based on these three things: measured RTT, smooth RTT, and deviation RTT. Whenever we do retransmission, we are not calculating RTT, so we are not updating RTO value with respect to RTT. But what we will be doing is, let us say previously RTO value is some 60 seconds. We are going to just double that particular value. Okay. Next RTO, new RTO value will be 120. Next again, let us say you have retransmission. Then we will be making RTO value as 240. Okay. So this is considered to be backup algorithm. Whenever we have retransmission, RTO value is not updated based on the RTT value, but it is updated like double the previous value. Whenever we have retransmission, we are just going to double RTO value. Okay, clear about how we are updating RTO?
Yes, sir.
Okay, you want me to repeat again?
Yes, sir.
Okay, so previously let us say RTO value is being updated with respect to RTT. Now RTO value is 10 seconds, let us say. Okay, you transmitted. Okay, we are waiting till 10 seconds to receive acknowledgement, but I did not receive acknowledgement. So basically, you will be retransmitting that particular segment. Whenever you retransmit this particular segment, we are going to update RTO value like this. Just double the previous value. Okay, let us say one more retransmission I had. Then I will make 40 RTO value. Okay, we are not following the derivations with respect to RTT here, but simply we are just doubling the values. But when we have, let us say I have successful transmission. In that case, I am not going to double this value. Okay. Clear or not?
Yes, sir.
Okay. Let me just show an image so that it will be more clear for you. Basically, we discussed this calculation for just for MTech, not for BTech student. Okay, so you can see the calculation of RTT here. Originally, we don't have any value. We just consider RTT equals to smoothed RTT. Okay, even if you want, what are these things? Smoothed RTT, all those things we can see here. Measure RTT is how long it is taking us to send a segment and receiving acknowledgement. Okay, so this will be like. Let me see if I can draw here. Okay, this is what I have. So I am transmitting something, receiving an acknowledgement. The amount of time we have from here to here, that is considered to be measured RTT. Okay, then smoothed RTT is weighted average of RTTM and previous RTTs. Okay, So we are going to consider previous measured RTTs, okay, and previous smoothed RTT. We are going to average these two things. Okay, already I have measured RTT, I have smoothed RTT. Average of these two things, weighted average of these two things, we are going to consider for smoothed RTT. Deviation RTT, deviation in RTT over various transmissions. That is what we are going to consider. See here, originally I don't have any value for RTT. We are just considering whatever the round trip time we have. After first measurement, smoothed RTT will become RTT-M. That is measured RTT. What is measured RTT here? It is equals to round trip time in the first case. Okay. Then after second case, we are going to update RTTS like this. 1 minus alpha multiplied with RTTS. So previously I may have some value, let us say 10. Okay, that 10 I am going to consider for RTTS, and presently I have some RTTM value. That value I am going to consider, multiply with half. We said weighted average of RTTS and RTTM, right? So based on these two things, we are going to consider what is the present smooth RTT value. When we go with RTT-D, that is deviation in RTT, that will be initially we won't have any value. For the first measurement, we are going to consider like 0.5 multiplied with measured RTT. Okay. From second onwards, we are going to consider weighted average of all these things. 1 minus beta into RTT-D plus beta into RTTS minus RTTM. Okay. So I got this RTT-D as 0.5 RTTM, right? That I will substitute for second calculation. Okay. And we will be calculating this second RTT deviation values. Okay. Then let me see if I have RTO value. See here, RTO, how it is calculated. We are calculating based on smoothed RTT plus 4 times RTT deviation. Okay. Typically, we use alpha and beta as 1/8 and 1/4. But whenever we get retransmission timeout, in that case, we are not considering RTO value as RTTS plus 4 times RTTD, but we are just doubling this particular value. Okay, clear, right? Yes or no? Okay. Next we have some algorithm like with respect to retransmission timer, how we can update rather than doubling the value, what procedure we can follow. Like that, we have some rules. Okay. So we have something called as cons algorithm, in which whenever a segment is not acknowledged, we are going to retransmit. That we have already discussed. Okay. When sending TCP receives an acknowledgement, it doesn't know if it is for original packet or for retransmitted packet. What we are trying to say here is, let us say I have like this. There are two cases. I transmitted something. I set retransmission timeout value. Okay. Receiver also updated with acknowledgement, but that is lost in the middle. Okay. Then second case is retransmission timeout is there. I transmit something. It is lost in the middle. Okay. After retransmission, I am going to send this one again, and again I am receiving acknowledgement. So basically RTTM means this will be starting from this point until this point. Okay. What happens in this case? This one, whenever I don't receive acknowledgement, retransmission timeout happens, and I am going to start again. Okay. But you have received acknowledgement for this one. Okay. If I measure round trip time, whether I should measure from here to here or here to here, because there may be another case wherein you transmitted segment, acknowledgement has traveled a longer path, and you retransmitted that. After that, you are getting this acknowledgement. Okay. Now the acknowledgement is coming for the original packet or the second packet retransmitted. how sender will come to know about this one? That is the question. Okay. So sender has no idea whether the acknowledgement is provided for the original one or retransmitted packet. That is the reason we are saying when we have retransmission, I cannot consider RTO value updation depending on whatever the previous calculations we have. Okay. Understood why, what is the difficulty in updating RTO as it is, right?
Yes, sir.
Okay. So basically RTT is calculated from the point when the segment was transmitted, but because of above mentioned point, we don't know what is the starting time, whether we need to consider original packet starting time or duplicated packet retransmitted packet starting time. So to overcome this, Khan has proposed an algorithm in which whenever we have retransmission, round trip time of retransmitted segment is not considered. Okay, that is what we said. Do not update RTT until you transmit a segment and get acknowledgement without any retransmission. Okay, and whenever we have retransmission, we are going to use exponential backup algorithm. Okay, so that is Khan's algorithm. Whenever we want to update retransmission value, RTO value or RTT value. Next, we have persistent time. Okay, we consider the case wherein receiver is updating a window size of 0. Okay, whenever whenever you receive a window size of 0, okay, this is happening at the sender side itself. Okay, let us say I get an acknowledgement with receiver window size 0. At this point, I am going to start this persistent timer. Okay, it starts persistent timer. When this timer goes off, the sending TCP sends a special segment called a probe. Okay, so previously what happened? We you have received a receiver window size of 0 and you are not getting any information from the server side. Okay, after some time, server has updated with new receiver window size, but because of some reason it lost in the middle. Whenever this one is lost in the middle, okay, if server and client they are not communicating with each other, there is no point wherein we will be able to communicate further. Okay, we will be ending up in deadlock situation. So to handle that, we are starting persistent timer. Whenever we receive this one, what we are doing is we are starting persistent timer, and whenever the persistent timer value goes up, let us say at this point it goes up, I am going to send a probe message. Okay, so this segment has only 1 byte of data with some sequence number, but this segment is never acknowledged. Okay, you are just sending a probe message telling like 1 byte you are going to send. Obviously, for that 1 byte, again receiver has to send an acknowledgement. When it is sending acknowledgement, it will advertise about receiver window size. Okay, so like that we will be overcoming the issue of deadlock situation. Okay, initially the value of this timer is set equals to retransmission time. If the response is not there, then the value is double. Okay, persistent timer, we are going to consider like retransmission timer value whatever we have, that we will be keeping initially. Then even though you send probe message 1 byte message, let us say within that timer value goes up, you are not getting any update value, you are doubling that. Okay, so you can see this process continues till we reach the value of 60 seconds, after which for every 60 seconds you are going to send a message. That means sender has sent an acknowledgement with receiver window size 0, you'll keep quiet. Whenever sender has an update, it will send an acknowledgement with receiver's window size updated value, but that acknowledgement is lost, so you are not going to keep quiet, but you are going to keep retransmission timer. Whenever persistent timer you are going to keep, that value will be equal to retransmission timer. Whenever this value reaches 0, you are going to double that one in case you are not getting acknowledgement, and you are not going to keep quiet. The sender is not going to keep quiet, but it will be doubling this value and continuously it keeps on sending when the value reaches 60. For every 60 seconds, it keeps on sending. So there is no question like all acknowledgements will be lost from server side, right? At least one acknowledgement will be able to reach or receive in case server is active. Okay, that is about persistent timer and how we can overcome the concept of like deadlock caused because of lost acknowledgement. Then we have something called as keep alive time. See, for example, you are not hearing anything from any one of the sides. Can be server or client. You don't want to keep as it is forever. Okay, we need at some point of time we need to close the connection. Okay, so to overcome the long idle condition between two TCPs, this value we are setting. Okay, the value is set to 2 hours, after which a probe segment is sent by server. Okay, after 10 probes, if there is no response, we are going to close the connection. Okay, so we are going to wait for 2 hours at server side. 2 hours you are going to wait for client. After 2 hours, if you are not getting any response, I'll send a probe message. Okay, for every 75 seconds. For every 75 seconds, I'm going to send a probe message. I'll do this one for 10 times. So 750 seconds I'll wait after 2 hours. Even after that, also you are not getting any response. I am going to close the connection. Okay. Yeah, if I don't hear anything from sender side, then receiver is going to do like. Okay. Then we have time wait timer, about which we already discussed, right? Time wait timer, 2 times maximum segment lifetime we will be waiting. Okay, clear about timers?
Yes, sir.
Yes, sir.